Hi students, in this video we are going to write the simplest form of sine inverse of 2x divided by 1 plus x square. You know that in this place we will try to bring sine function, sine theta or sine alpha something, so that it will be easy for us to solve the problem. So now what we do is we write the sine formula here. If you look at this 2 tan a divided by 1 plus tan square a, we have sine 2a, and then 2 sine a cos a is equal to sine 2a. We need to choose the suitable one according to this concept. If you look at this 2 sine a cos a, definitely it will not fit into this because we have numerator denominator. Here we do not have such concepts. But if you look at this 2 tan a divided by 1 plus tan square a, it suits the problem very well. So what we can do is, in place of x, if we substitute tan alpha, in this place we can bring sine 2 alpha. So we assume that let x is equal to tan alpha. First, just for future use, I am just writing alpha is equal to tan inverse of x. Now we focus on this. Let x is equal to tan alpha means in this expression wherever we find x, in which we must substitute tan alpha. So sine inverse of 2 tan alpha divided by 1 plus tan square alpha. We know this formula. This is equal to sine 2 alpha. So we have sine inverse of sine 2 alpha. As per inverse trigonometry concept, our final output will be 2 alpha. But we need the answer in terms of x. So in place of alpha, we can substitute this tan inverse of x. So 2 tan inverse of x is the required simplest form of sine inverse of 2x divided by 1 plus x square. I hope you understand this problem. It is a very easy one. Now we will move on to the next question. Tan inverse of x divided by root over of a square minus x square, where modulus x is less than a. Here we have tan inverse. So in this place we are trying to bring tan here. You just look at various formulas for tan here. We know that 1 plus tan square theta is equal to secant square theta, from which we can say tan theta is equal to root over of secant square theta minus 1. We will check whether this concept can be applied here. If you look at this formula, tan theta is equal to root over of secant square theta minus 1 divided by minus 1 is here. Here denominator is 1 and in the numerator we have root over of secant square theta minus 1. But here it is x divided by root over of a square minus x square. So this concept cannot be applied. It will be a lengthy problem if we substitute it. So we will try to use some other formula. We know that tan theta is equal to sin theta by cos theta. It is in the fraction form. So if we try to bring sin theta divided by cos theta, means in this place we can bring tan theta. So we will try to apply this concept, and we will consider one more formula also, that is tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta. So here also we have fraction numerator and denominator, but in the denominator in the question the square root is there, but here we do not find square root here. So compared to this one, it may not be convenient for us to substitute this. So here we will try to use sin theta divided by cos theta concept here, but we will try to write this cos theta in terms of square. We know that sin square theta plus cos square theta is equal to 1, from which we can write cos square theta is equal to 1 minus sin square theta, and cos theta is equal to root over of 1 minus sin square theta. So if we substitute this value here, sin theta divided by root over of 1 minus sin square theta, it will be suitable here. So what we say is, so what we can do is, let us assume that x is equal to a sin theta, because here we have a square, that's why it is considered as a sin theta, from which we can say that alpha is equal to 1 by a into sin inverse of x. You know that it can be applied in the future. So we are just substituting a sin alpha in the place of x. We are getting this, and we are taking a square out of square root, which comes out as a, and then root over of 1 minus sin square alpha, which is cos alpha. Now we got sin alpha divided by cos alpha. It can be written as tan alpha. So our aim is to bring in this place tan alpha, we brought it, and tan inverse of tan alpha gives us alpha. Already we calculated alpha value, which is 1 by a into sine inverse of x. Hence 1 by a sine inverse of x is the required simplest form of tan inverse of x divided by tan inverse of x divided by root over of a square minus x square. I hope you understand this problem also. Thank you students. Thanks for your cooperation.